For a long time, we've looked at the sun and thought we understood its limits. We accepted a ceiling, but maybe we were looking at the wrong limit all along. We're not just improving solar tech anymore. We're rewriting the rules to launch a whole new era of energy.
So let's just get straight to it. The real bottleneck in solar power isn't about better manufacturing or clever engineering. It's about physics. It all boils down to one single particle of light, the photon. And to break through, we had to rethink everything we knew about converting light into power.
And that journey starts with a barrier, a wall really, that's been standing for over 60 years. It's a fundamental constraint that has defined the entire history of solar technology, the quantum limit.
Now, you need to understand, this isn't just some benchmark. The Shockley-Queisser limit is a hard rule of physics. It basically says that any solar cell made from a single material, like the silicone in almost every panel out there, can only ever convert a specific limited amount of sunlight into electricity. It's baked into the laws of thermodynamics.
And what's that limit? It's about 33%. For more than half a century, that was the theoretical best we could ever hope to achieve. Just think about that. 2/3 of all the incredible energy the sun pours down on us, just gone, wasted. But that's all changing.
So why? Why is so much energy lost? Well, you can think of a solar cell as being a little picky. It's tuned to absorb a very specific energy level, which is called its band gap. If a photon of light comes in with too much or too little energy, if it's not a perfect match, the cell just rejects it. And that rejected energy becomes waste heat.
And that waste heat is the silent killer of performance. Just look at this. As a panel gets hotter, its efficiency just tanks. For every single degree above a comfortable 25 Celsius, you're losing power. And in the real world, panels can easily hit 60 degrees or more. That's a massive, massive loss of power.
Okay, so if a single material is too picky to do the job, what's the solution? Well, the answer is actually pretty elegant. You stop trying to catch the whole rainbow with just one net. Instead, you engineer a system to capture the entire spectrum, one precise layer at a time.
And this is where it gets really clever. A normal single-junction cell is basically a one-trick pony. It's good at capturing one specific color of light. But a multi-junction cell? That's a whole team of specialists stacked right on top of each other. Each one is a master at capturing its own slice of the spectrum. It's a total game changer.
So, here's a look at how that team works. Right at the very top, you have a layer of gallium indium phosphide. Its only job is to grab the highest energy light, the blues and the violets. Just below that, gallium arsenide is perfectly tuned for the mid-range light. And at the bottom, a classic silicon or germanium layer mops up all the low-energy reds and infrareds. It's a perfect cascade. Almost nothing gets wasted.
You see, by layering these incredible materials, we're not just making tiny, incremental gains. We are absolutely shattering the old records and playing in a whole new league.
And here is the proof. 47.1%. That's a world record efficiency for a 6-junction cell. This is a number that just a few years ago would have sounded like pure science fiction. It's a quantum leap past that old 33% wall.
And this revolution isn't just happening in exotic high-end cells. Look at this. This crystalline silicon perovskite tandem cell just smashed its own record, hitting nearly 35%. We're seeing this breakthrough happen across the board. High efficiency is becoming the new standard.
But what about that heat? The leftover energy that even these amazing new cells can't quite capture? Well, the next great leap forward comes from seeing it not as a problem to be solved, but as an opportunity, a second source of fuel, just waiting to be tapped.
This single question changes everything. Because when you reframe the problem like this, you unlock a path to efficiencies that were once literally unimaginable. We're talking about total energy capture.
And the key technology here is the thermal electric generator, or TEG. It's this remarkable solid-state device that does something that frankly sounds like magic. It creates electricity purely from a difference in temperature. Put simply, if one side is hot and the other side is cool, it generates power. It turns that waste heat directly into more electricity.
So, what happens when you pair one of these ultra-efficient multi-junction solar cells with a TEG bolted onto the back? The results are just staggering. We are talking about a hybrid system with a total conversion efficiency of over 50%. Let that sink in. More than half of the sun's total energy, both light and heat, is turned into usable power.
And you have to understand, these are not just experiments in a lab. These are the building blocks of a global industrial revolution. This tech is ready to completely reshape our entire energy landscape.
Now, let's be real for a second. The cost. This advanced technology absolutely has a higher upfront price tag. A complex hybrid system just costs more to build than a simple standard solar panel. But that is only half of the story.
Because the other, far more important half of the story is the lifetime cost of the energy it produces, and that cost is plummeting. Projections show the cost of utility-scale solar dropping to an unbelievable $17 per megawatt hour. This tech isn't just on track to be competitive, it's on track to become the cheapest form of power on the planet, period.
And the applications, they're everywhere. We're talking about powering massive utility-scale plants, creating clean solutions for industry, making residential homes completely self-sufficient, and even powering the equipment we need to create green hydrogen. This is a complete energy transformation.
So, we started this journey by challenging a fundamental law of physics. We figured out how to tame the entire light spectrum, we turned waste heat into fuel, and we unlocked a whole new economic reality. The old limits are gone. They're broken. So, the only question left is, what impossible dream will we power next?